Okay, this is part 2 of 8.13 AP Calculus BC curriculum, arc length of smooth planar curve. We're going to do a couple of examples now where it's pretty easy to calculate by hand. These won't be nice, pretty simplified examples, but they will, to calculate the integrals by hand won't be too hard. So we're going to start by finding the arc length of the curve f of x equals x plus 1 to the 3 halves from x equals 1 to x equals 5. Recall that the arc length s is equal to the integral, in this case from 1 to 5, of the square root of 1 plus dy dx all squared times dx. Remember, that's not the second derivative under there, that's the first derivative all squared. So to start with, we're going to have to find the first derivative, dy dx, and that's going to equal 3 halves times x plus 1 to the 1 half. So that means our arc length formula is going to be the integral from 1 to 5 of the square root of 1 plus, when I square 3 halves, I get 9/4, and this is going to be times x plus 1. And that's all dx, because when I square x plus 1 to the 1 half, I'm going to get x plus 1. And so this, let's simplify what's underneath the square root, the integral from 1 to 5 of the square root of 1 plus 9/4 x plus 9/4. That's times dx. And recall 1 is 4/4, so we can call this the integral from 1 to 5 of the square root of 13/4 plus 9/4 x, all times dx. And if I want to integrate that, I'm going to make a u substitution. I'm going to let u equal 9/4 x plus 13/4. That's going to make du equal to 9/4 dx. I have my dx, so to switch this to, in terms of u, I'm going to have to get a 9/4 here. That's outside the square root. To make that happen, I'm going to have to multiply by 4/9 on the outside of the integral. And that's going to allow me to rewrite this integral as the integral. Now let's figure out our change in substitute or limits of integration. The lower limit of integration when x equals 1, then u when x equals 1 is going to be 9/4 plus 13/4, or 22/4, which is, of course, 11 halves. And when x equals 5, our upper limit of integration, is going to be 45/4 plus 13/4, which is going to be 58/4, or 29 halves. So we're going to now, when we change the variable to u, we're going to end up integrating from our lower limit, 11 halves, to our upper limit, 29 halves. And now we're going to have 4/9 times u to the 1 half du. When we integrate that, we get 4/9 times, this is going to be, the new exponent is going to be 3 halves, so we're going to divide by that, get 2/3 times u to the 3 halves. And that's going to be evaluated from 11 halves to 29 halves, which is going to be, I can pull the constant out front, it's going to be 8/27 times 29 halves raised to the 3 halves power minus 11 halves raised to the 3 halves power. And I'm going to leave that like that, because if you had to do this by hand, that would have been sufficient. And we're not going to try to raise 29 and 11 to the 3rd power and all that good fun stuff. But that would be the expression that would give you the arc length of the curve. Where we're at, x plus 1 to the 3 halves power from x equals 1 to x equals 5. Let's do another example. This time, we've got a separate curve, y equals 2x to the 3 halves power. And that's equal to, or from x equals 0 to x equals 10. So again, remember the arc length is the integral from, in this case, 0 to 10 of the square root of 1 plus dy dx all squared under the square root, then times dx on the outside. And so that's going to be, let me find dy dx, which is going to be 3 halves times 2x raised to the 1 half. And recall that 2x is inside the exponent, so we can't cancel the 2's there. So that's going to be our dy dx. So now when we square that, let's see, we're going to get our arc length is going to be the integral from 0 to 10, the square root of 1 plus, and when I square 3 halves, I get 9 fourths. And then when I square 2x to the 1 half, I just get 2x, and that's all times dx. So let's go ahead and simplify that inside. That's integral from 0 to 10 of the square root of 1 plus. Now the 2 cancels 2 down here. We end up with 9 halves x. And that's times dx. So now I'm going to let u equal 9 halves x plus 1. And du is going to be 9 halves dx. So once again, I need my 9 halves out here. That means I'm going to have to multiply by 2/9 here. It's going to give me the integral, or sorry, 2/9 times the integral from, let's do our u substitution and change our u variables. From when u is 0, or when x is 0, u is going to be 1. And when x is 10, u is going to be, that's going to be 45 plus 41 plus 1. Let's just say 9 halves times 10 plus 1. That's 90 halves, or 45 plus 1. So yes, that's 46. And that's going to be the integral, or sorry, 1/2. It's u to the 1/2 power, du. And when we integrate that, that's going to be our 2/9 times, this is going to be u to the 3 halves divided by 3 halves, or times 2/3. And so this is going to be evaluated from 1 to 46. That's going to be 4 over 27 times, this is going to be 46 to the 3 halves minus 1 to the 3 halves, which is just minus 1. And that would be our intervals. Those are a couple examples that we can do by hand to calculate the arc length. And next we'll do some on the calculator.